Good afternoon, students. In the last class, we have discussed about the combination of capacitors, in which we have seen that if the capacitors are connected in series, then the formula will be 1 by Cs is equals to 1 by C1 plus 1 by C2 plus 1 by C3 and so on. That means if these capacitors are connected like this, if suppose n capacitors C1, C2, C3 and so on up to Cn are connected in series, then the effective capacitance of this is given by this is the formula. That means in series combination, we know that 1 by C1 plus 1 by C2 for 1 by C3 and so on like this. We have learned this one. Similarly, if the capacitors are in parallel means how we have already derived. Suppose this is, say this is C1, C2, C3 and so on. Say this is Cn. This one first plate of this capacitor and the first plate of all the capacitors are connected to one terminal, and the second plates of all the capacitors are connected to another terminal. Then this combination is said to be a parallel combination. Then the effective capacitance between this A and B is given by, for this the formula is given by C parallel, which is equal to C1 plus C2 plus C3 plus and so on plus Cn. So keep in mind that if the capacitors are in series, then the formula will be 1 by inverse of its capacitance. We have to add up this. Similarly, if the capacitors are in parallelly connected, then we have to add this capacitance directly, direct addition only. So if suppose now in a problem, suppose the combination of this series as well as combination of this series and parallel both are given in a problem, then how to solve? Let us see this. Suppose say here, suppose this is the capacitance, this is one more capacitance. Say this is the capacitance C1, this capacitor is C2. This is again connected to one more capacitor. Say this is C3. Now this is one end, this is one more end. Now is asking what is the effective capacitance between A and B. So between A and B, if suppose only this one is there, suppose this is not there, then between this A and B we can say that these two are in series. Means we can tell that 1 by C1 plus 1 by C2 we can write if this is not there. But here, if it is like this, if it is one more capacitor connected like this, then we cannot say that this is 1 by C1 plus 1 by C2. Now we have to consider this also. Now what is the effective capacitance of all? What is the effective capacitance of the three combinations we have to calculate? So for this first we have to calculate this one initially. For this we know that simple formula, that is 1 by Cs is equal to 1 by C1 plus 1 by C2. This implies that C1, C2, C1 plus C2 we can say. If you reverse it, Cs is equal to 1 by this reverse, this will also reverse. C1, C2 by C1 plus C2. So these two capacitors combine to make one single capacitor of the value of the capacitance value Cs. So these two C1 and C2 combine to become Cs. Means next this diagram can further be written as like this. Now it became single capacitance of value Cs. So C1, C2 combine to become what? Cs. So effective capacitance is this one. So therefore now here one more is there, that is C3. This is A, this is B. Now what is the capacitance of these two capacitors between A and B? For this we have to, how these two are in parallel. These two are initially, these are in series. Now after these two combine to make one. After this, now these two are again, these two are how they are made? Parallel are there. So for the parallel, what is the formula? Cp is equals to, this is Cs plus this is C3. For parallel, we have to add up directly. For series, we have to write like this. Okay. So therefore, Cs means what? What is Cs means? That value. That is C1, C2 by C1 plus C2 plus C3. On solving this, we will get. So C2 value, we are getting this much. So finally, the capacitance between these two is given by this formula. So this is the how we have to solve. So this is how we have to solve. So whenever if it is given in a complicated, if they are given in both series as well as in parallel, then first of all we have to calculate individually series combination, otherwise individually parallel combination. We have to separately we have to calculate. Then we have to equate all as we have done here. First I have calculated for this series. Thereafter, I kept here. Now these two are again how they are like parallel. Again, I have applied the parallel formula. So in this way, we can calculate any bigger combination. Let us see some examples. Then we'll come to know. Let us see some examples. Suppose say the same I will take. Suppose say this is of 1 microfarad, this is of 2 microfarad, this is of suppose say 3 microfarad. These two are connected to A and B. Then how to solve this problem? What is the effective capacitance? Like this, they will give a circuit diagram. They will give and they will tell find the effective capacitance between A and B. Between A, B, if they ask, then what we have to do? First, we cannot do these two as parallel. We also cannot do these two as parallel. Why? Because these two are parallel, one more is there. So we cannot do. So first we have to do these two as series first. So first I will take that 1 by Cs is equals to 1 by C1 plus 1 by C2. This is suppose say C1. This is suppose say C2. This is suppose say C3. Therefore, 1 by 1 micro plus 1 by 2 micro. Therefore, 2, this will come here, 2 plus 1, which is equals to 3 by 2. So 1 by Cs is equal to 3 by 2. This implies that Cs, I want this Cs, means inverse it. That is 2 by 3, that much of microfarad. See here, micro means 10 power minus 6. That after solving like this, we have to keep the value. Why? Because he has given in micro. So we also should have to take the in terms of micro. So therefore I got this value here. Now this circuit becomes now this entire thing become what? Cs. That is, this is Cs is equal to 2 by 3 microfarad, and this is C3 which is equal to 3 microfarad. This is what we got. Now, what is the effective between these two? Effective capacitance between these two? These two are how they are made. How these two are made? Parallel. Therefore, I can say Cp is equals to Cs plus C3. Cs plus C3. Therefore, Cs is how much? 2 by 3. This one is 3. Therefore, take 3 as LCM. Then 2 plus this will cancel to get 9. Therefore, this will be 11 by 3 microfarad. So, directly, if the number is there, means very quickly we can do, very easily we have done within few steps. So, this is how we can calculate the effective capacitance between the both A and B. So, this is the problem. Similarly, some another model, let us see. Suppose say Now, the diagram sometimes they may give like this. Let us say I will give some names. Suppose say this is 1 microfarad. This is say 2 microfarad. Say this is 3 microfarad. Say this is 4 microfarad. This is 5 microfarad. Suppose in this way it is given. Now we have to calculate the find capacitance or effective capacitance between A and B. That is AB, like this. Find capacitance between A and B. That is the question here. So now in this case, if you see carefully, these two, how they are means nothing is there between these two. Means no another capacitor is there. No any other capacitor is there. That means I can say that these two are again in series line. These two are series. That means this diagram I will draw like this also. This is called suppose 3 microfarad. This is 3 microfarad. If I pull this one that side and if this here also if I bring this side, then this can be written as here like this. Four microfarad. This side it is 5 microfarad. Say I have just bent this one that side, this one has this side. So 4, 3, 5, 4, 3, 5. And these two capacitors are in between 4, 3 and between 3 and 5. That means between 4, 3 it is started. That means I can say like this. Five resistor is in between 3 and 2. 5 resistor is in between 3 and 2. This is 2 microfarad. This is 1 microfarad. Whereas a 4 capacitor, 4 microfarad is in between 1 and 3. 4 is in between 1 and 3. So in this way we can draw. Means this circuit can be simply drawn like that also. So it will make you easy to calculate the effective capacitance. See now here these two how they are made. These two are in series. So series means what we can say 1 by CS is equal to 1 by 1 micro plus 1 by 2 micro. Means I can say here 2 plus 1 means 3 by 2 or CS is equal to 2 by 3 microfarad. So this became. So now the next diagram for this I can say 4 microfarad, 3 microfarad, 5 microfarad. This entire thing became how much? This much. So this is between 3 only. So I can say this as CS, which is equals to how much? 2 by 3 times of microfarad. Now again, how these two are? We cannot take these as series. First we have to calculate this. Then what are the value we'll get? With that again these are in series. So first we'll calculate this as a parallel. These two are parallel. So in this case parallel formula. C parallel is equals to what is the formula for this? CS plus C3. CS plus C3. That means 2 by 3 plus 3. That means what? 11 by 3 microfarad. So C3 I am getting how much? 11 by 3. That means this entire thing become how much? 11 by 3. Same we have calculated previous first question is like this only. These two are extra I have given now. Previous only I have given this one only. Very easy. So therefore, now this circuit can further be written like this. This entire thing what will happen? This entire thing become parallel. That is this one. That is CP, which is equals to 11 by 3 microfarad. This is already given. That is 4 microfarad. And one more here is there. That is 5 microfarad. So now the effective capacitance between A and B. Now see. Now if you see these are all how they are in series. So series means that formula. What is that? 1 by CS is equal to 1 by 4 plus 1 by this value, that is 11 by 3 plus 5. This 3 will go up, means I can write this, okay. 1 by 4 plus 3 by 11 plus 5. Therefore, if you take a LCM for this, sorry, here we have to 1 by 4, this is 1 by 5. So therefore, if you take a LCM for this, what will be LCM for this? 4, 11 and 5 is there. That means how much? 55 into 4. 22. So 220 we can get. So here the LCM is said to be 220. 220 we are getting LCM. So this will be cancelled by how much time? Means we can say 55 times it can be cancelled. So 55 plus it can be cancelled by how much? Means 20 times we can say. And plus it can be cancelled how much? Means what we can say 44 times. Correct? 5 4 are 22. Yes, this is. So therefore, if you add this, you will get 55, 44, 20. Means 9, 11. So 119. So 119 by 220. That much of microfarad. So sorry. So this is 1 by CS value. This is 1 by CS value. Therefore, my requirement is what? Only CS is required. That means this is 1 by CS value. This one is. Therefore, CS means what? Just inverse it. That is 220 by 119. So this much of microfarad will be there. So the effective capacitance between A and B is this much. So this is the effective capacitance between the two, between these two ends A and B. This is. So in this, how we can solve the effective capacitance between any two ends, we can calculate in this way only. Now let us discuss about the next topic, that is, so we can, so in this way, in the similar manner, whenever a given circuit, if the circuit is given complicated like this, first we have to identify which two are in series or which two are in parallel. Then first we have to calculate those series first, otherwise those parallel is there, those parallel first. Then after that we have to take the remaining circuit again, once again series or parallel. So in this way we have to reduce those steps. We have to keep on solving. So finally, until we'll get one complete either series or either parallel, we have to get. So still then we have to work out as we have done similarly. Okay. Now let us see next topic: energy stored in a capacitor. So this is the important question for our theory purpose. So many times they have asked this for a 5 marks, like this they are asking. So it is for 5 marks, or they may give for 3 marks also, depends upon the question paper setting. So, but this is important question. Okay, this is important one. Let us consider, say how I am deriving. So energy stored in a capacitor. Let us consider I am taking two uncharged plates. Suppose say these two are 1 and 2. These two are uncharged plates. Uncharged means what? Neither it has having any positive or negative, means neutral charge you can say. So such a plates I have taken. Means these plates are like this. Carefully see. This is the plate and also this is the plate. Like these two plates are there. This is having area. Say that area is capital A. For this also both are having same area. Say that is area A. And these two are separated by a distance. Say that is B. Okay. So area of the plate is how much? Area is how much? A. So now here what I will do is, let us from this neutral plate to, I am taking a charge, that is a positive charge I am taking from this, or I am extracting a positive charge from this plate I am keeping on this. So when I draw a, when I will take a small bit or a bit of charge, that is positive charge, if I take, say plus dq is the small amount of charge which I am bringing, which I am taking outside from this second plate, and this I am bringing here and I am placing on it. So what happens if I take all the positive charge from this plate, then this plate will start becoming negative, and this is gaining of positive charge. That means if I am taking all the positives from here and I am placing here, then this plate will become what? Positive in charge. That means here, if you carefully see, here from our second plate, dq is the amount of small charge which is carried from second plate to first plate bit by bit. Means every time I am taking dq of small charge from here and I am placing here, like this I am placing. So in this case, I have to do work. Why? Because see, this is become a positive. Positive means what? This is higher in potential. That means as I am taking all the charges from here and I am placing here, means this is becoming a more potential, that is higher potential becoming. So this is a higher in potential and its potential keep on decreasing. Why? Because I am taking all the charges. So its potential keep on decreases and its potential keep on increases. So here, to bring one charge from lower potential plate to higher potential, it alone will won't go. So I have to work, I have to do some work to move our charge from lower potential to higher potential. For better understanding, for example, say this is a ground which is at a lower potential, we know this. At a height, this is called higher potential. The potential energy at this point will be more. Why? Because potential energy formula generally mgh. So this is a higher potential. If you leave any stone or any body, then without any external work, the body itself will come down. No, you no need to do any work to move a body from higher potential to lower potential. But the same body, if you lift from lower to high, will it go alone? No, some external work has to be done. That means I have to lift the body up. So for this, against the gravity, I have to do some work in lifting this body. That means if any body move from lower potential to higher potential, we have to do some work. Otherwise, it won't move. So in the similar manner, here also, here this is of a lower potential. So in this lower potential, to move from lower potential to higher potential, this positive charge, I have to do some work against this electric field. Here the electric field is created in this direction. Electric field E will be from positive to negative. So as we have seen that here, against the gravitation, I have to pick it up. In the similar manner here also, the positive charge has to move against this positive plate. So for this, I have to do some work. Okay, so for that work, I will calculate first. Let us consider that at any instant of time, let us say these both have been acquired some charge. Say this charge become minus q and it is of, say this is plus q. Minus q and plus q is the charge attained on the two plates at any instant of time. At that instant of time, let the potential of this is given by, let V is the potential developed between these two. Means plus V and this is here, this potential is minus V. So here V is the potential attained between these two. So how much potential is there with V? At that instant, what is the charge is this much. Then let us say the capacitor, now it became positive and negative, means we can say that this is the capacitor, we can say. Let us say the capacitance of this parallel plate capacitor, say that is C. C is the capacitance of a parallel plate capacitor. Therefore, let Q be the, sorry, Let dq be the charge moves from bit by bit from plate 2 to 1. So 2 to 1 bit by bit I am taking dq of charge. So therefore let any instant of time t, the charge on the plates is, say, that is q, and the potential is, say, that is v. Therefore the potential between the plates, that is this V, is given by, general formula is there. What is the formula? We know one formula. What is it? We know that Q is equal to CV. One formula we know. Therefore, from this I can say that V is equal to Q by C. So I can write here Q by C. So here V is nothing but potential acquired on this plate of capacitor C when the charge on it is Q. So that Q I have taken. Say this as potential developed on this is given by, say this as equation 1. Therefore, small work done in moving a charge dq bit by bit is given by. So from here to here, this charge dq I am moving here. So for that I am doing a small work. So let us say that work is given by dw is equal to, we know that what is the charge moving, that is dq into potential. We know that one formula, that is from the definition of electric potential. What is that? V is equal to work by charge. So from this I can say that dw is equal to charge into voltage. We can say this formula. Okay, so here which charge I am moving is here. dq is the small charge I am moving. So that's why I have taken dq. So this is the small work done. So this is the small work done in moving dq charge. But finally, how much I am moving? So small charge I am moving like this. So finally, when the entire charge I have moved here, then the total charge on it becomes, say, that is plus capital Q, and at that time the entire negative charge will be left here, say that is minus capital Q. So here plus capital Q minus capital Q are the maximum charge on this plate, and maximum charge on this plate is minus Q and this is plus Q. Okay, then for that I have to do how much work means I have to do a work. Therefore, on integrating above equation within proper limits, that is plus Q to minus Q. So, small work done is this one. To store total charge on it, that is the plate should acquire total charge, that is plus capital Q, here minus capital Q. That means that much of work I have to do. So for that I have to integrate this smaller work within the limits. What is that? Minus Q to plus Q. So that means we have to integrate this value. dw is equal to integration of dq into v. Therefore here minus Q to plus Q minus Q to plus Q we have to integrate. So therefore here minus Q plus Q. Here V means what here from this equation? V means here Q by C. So I can write here Q by C. So from this entire thing I will call it as a W. Now that W is equals to here 1 by C. Here 1 by C is the capacitance of a capacitor which is constant. I will keep it outside. Therefore, 1 by C integration of Q into dQ we can write. Minus Q plus Q. So I can write this one like this. So therefore, this is nothing but we know the integration of x into dx formula. X into dx, x power is nothing is there is 1 we can say. So for this I can say x power 1 plus 1 formula 1 plus 1 by 1 plus 1 that is x square by 2. We know that very well. So here the same we can write here 1 by c into this is x dx like it is like this only. So this can be written like this that is q square by 2. This is minus q, this is plus q. So therefore 1 by c into upper limit minus lower limit we have to calculate. We have to substitute. Sorry. Here the limits will be 0 to q. Why? Because see, as I told you previously, plate is there. So initially, when entire charge is initially no charge is brought here. Initially no charge is brought. That means 0 charge. So when I keep on storing here, this will become negative and this one start becoming positive. So finally it becomes what? Capital Q. So from 0 to capital Q I have stored. So initially no charge. So bit by bit I am storing here. That is dq first. Again dq like that. So initially no charge. So finally this became what? Capital Q charge. So I have to integrate this equation between 0 and Q. So I have to equal this limits that is 0 to Q we have to integrate. That is 0 to Q, not minus Q. Here 0 to Q. So here we have to integrate the above equation within the limit that is 0 to Q, not minus Q. Why? Because it is charge start from 0 to capital Q. So therefore, now we can substitute this value that is this 2 will keep outside. Therefore, Q square minus this will become 0 square. So instead of this Q, once you substitute capital Q, once you substitute the 0. So therefore, this will become what? Q square by 2c. So this is the work done. So this work done is stored as potential energy, and this is called U is equals to I can say Q square by 2c. See, once again I will tell you. Let us consider two plates are there. One is plate 2 and one is of plate 1. Okay. Initially, these both are neutral, no charge. So initially, when there is no charge, is 0 charge on this plate. Then finally, what I have done is now I have bit by bit I have moved the charge, dq charge from this plate to this plate. At that time, this will become negative and this will gain the charge. That means this will become positive. So finally, it becomes dq. At last, it becomes capital Q. Initially, there is no charge, that is Q. So its limit will be between 0 to Q. 0 is the initial charge, nothing is there. Finally, after entire charging, that is entire charge have been brought from here to here. How much you have brought means say that is capital Q. Fully charged. Then 0 to Q you have to integrate. So for that purpose, at any instant, let us say V is the potential. At any instant of time, let us say Q is the charge on the plates. Therefore, V is equal to Q by C is the potential at any instant of time t. Therefore, how much work done in bringing a small dq charge? To bring a small dq charge from here to there, how much work is done means that work is given by dq into V. dq means what? Which charge I am bringing from here to there, like this. V means what? At that instant, whatever the potential is there. Say that is V, this one. So that is this one, V. This is V. Therefore, from this is a small work done to move dq charge. But I want to charge this entire capacitor up to capital Q. 0 to capital Q, how much work I have done on storing this charge. So for that I have to integrate this equation within the limits 0 to plus Q. So 0 to plus Q means here dW means dQ into V. This I have written. What is V here? V is nothing but we know a formula. What is that? Q by C. So that's what I have substituted here. V means Q by C. This C is constant. I have kept outside. Therefore, Q into dQ. Integration of Q dQ is nothing but similar to this formula. Integration of x dx. Power nothing is means 1. So x square n plus 1 by n plus 1 like a formula. That is x square by 2. So similarly, this also Q square by 2 we can write. So now after that, this will be this upper limit and lower limit we have to substitute. That is upper limit minus lower limit we have to substitute. Therefore, this will become 0. Therefore, Q square by 2C. So this work done will be stored in the form of potential energy, that is U is equal to Q square by 2C. Okay, this is the energy stored between the two capacitors. Important question this one is. Now, this can be written in different forms also. See, as we know that U is equal to Q square by 2C. This is the formula we know. This formula we have derived just now. So, this energy in terms of charge and capacitor, in terms of different values like charge and voltage or voltage and capacitor, also we can write this energy value. In terms of potential or capacitor also we can write. For example, see here, since we know that Q is equal to suppose CV, we know this general formula. Q is equal to CV. So this Q value I will substitute here, then this U will become CV whole square by 2C. Therefore, C square V square by 2C. CC get cancelled. Therefore, this can be written as half C V square. So this is also energy only. This is also expression for the same energy, but in terms of capacitor and potential, and this is in terms of charge and capacitor. Okay. Therefore, now also we can say, see this value I have substituted here. Now what I will do is, now I will substitute here C value in this case, then I will get one more one. That is, since we know that U is equal to Q square by 2C, since we know that Q is equal to CV, from this C is equal to what we can write Q by V. Now if I substitute C value Q by V, if I substitute here, then we can say Q square by 2 into C means what we can write Q by V. Here Q will get cancelled, this V will go up, that means QV by V. So this is also one more form. So therefore, this is the energy formula in terms of charge and capacitor. This is also same energy formula in terms of capacitor and voltage, and this is also same energy in terms of charge and voltage. So therefore, I can write U is equals to Q square by 2C, and also equals to half CV square, and also that is equals to QV by. So this is called energy of the capacitor. So these are there are three formulas are there in different parameters. U is equals to Q square by 2C, which is equal to half CV square, which is equal to QV by 2. We know this formula. Keep in this mind. Now we are going to calculate the expression for a energy store in a capacitor if the capacitors are arranged in parallel or it is arranged in series. Let us see what is the capacitance value. For example, first one, energy of the capacitors when connected in series. That means suppose this is C1, C2, C3. Suppose I am taking for these three, or otherwise I will extend this. Let it be. This is as a Cn. Then energy for the total energy is equals to, we can write general formula. What is that? Q square by 2 series, we can say. See here, this is how it is meant. These are all in series combination. So therefore, we know that in case of series, the charge will remain same. The charge will be remaining same. So the total energy between the A and B is given by Q is equals to charge is same. That is Q square by 2 into CES. Mean this is in series. So therefore, this can also be written as Q square by 2 into, this is 1 by CS we can write, into 1 by CS also we can write, which is equals to Q square by 2 into, what is 1 by CS mean? These are in series, mean 1 by C1 plus 1 by C2 plus 1 by C3 and so on plus 1 by Cn. So therefore, if I multiply this Q square by 2C1 plus, if it is go there, Q square by 2C2 plus Q square by 2C3 and so on plus Q square by 2Cn. So this formula Q square by 2C1, it is like this only, Q square by 2C. So this is the potential energy of the first capacitor, that is, say that is U1, plus second one, this is, say that is U2, this is U3 and so on. That means the potential energy in case of series, it will be direct added only. That means if they are given two or more capacitor, if they have given the energy of the three capacitor connected in parallel, then what is the total energy? Means all the three energy we have to add up like this. Directly we can add. If they have given parameter like Q and charge, substitute. If direct only energy values are given for these three, then we have to directly add up. Okay, why? Because this expression shows that energy is nothing but it is the sum or the algebraic sum of all the individual energies of all the capacitors. Now let us see for the parallel. Parallel. Suppose say this is a capacitor C1, C2, C3 and so on, Cn. Now, what is the energy of this capacitor of this combination when they are connected in parallel? Of this combination, what is the capacitance? Means we can say that U is equals to one formula. We can take any one of the formula. Suppose I am taking here second formula. If I take 1 by 2 into C into V square, if I take, then here as we know that in case of parallel, charge will be dividing, the potential will remain same. Across all the capacitor, the potential is same, only the charge is divided, we know. So therefore here potential will be same, but the capacitance here, how they are parallel. Say I will tell it as a Cp, half Cp into V square. V is common for all. So therefore here into, what is Cp means here? In parallel, how we can write? Direct adding C1 plus C2 plus C3 plus and so on plus Cn into V square. If I multiply this this one here and this one also. If I multiply, then I will get half C1 V square plus, again for this, half C2 V square plus half C3 V square plus so on plus half Cn V square. So here this is also is nothing but like this one only half CV square. So C1 means this is the energy of the first capacitor. Say this is U1. This is also for a second U2. This is also third U3 and so on plus U1. So in case of parallel also we are getting the same result as that we got in a series. That means in series or parallel the energy is nothing but directly add. Okay, so in case of series or parallel, what is the total energy of the capacitor? Means energy of the capacitor is nothing but it is the algebraic sum of all the energies of each individual capacitors. So this is how we can say, right? Let us calculate the expression for the energy density in a parallel plate capacitor. As we know that this is a parallel plate capacitor. If this is positive, if this is negative, this is positive, this is negative, that means the electric field line will move from positive to negative. We know this very well. Then as we have derived the expression for a capacitance of a parallel plate capacitor, in that case we have discussed that at this point outside the plate the electric field will be 0 and this side also electric field will be 0, but between these two plates the electric field will be non-zero. That is, the electric field will be the sum of these two. That means for one side sigma by 2 epsilon naught, for this also sigma by 2 epsilon naught. Therefore, the electric field at this point is given by sigma by epsilon naught. So we know this formula very well. That is, electric field between this is this much. We know this. We will use this formula. Keep it like this. Therefore, energy stored in a capacitor is given by, just now we have derived, that is U is equal to Q square by 2C. We know that this is the expression for energy stored between the two plates, that is given by Q square by 2C. We know this formula very well. And since we also know that sigma is equal to charge by area. Charge by area is called surface charge density. Therefore, here charge is equal to, I can write sigma into A. And also, since this is the area of the, say the area of the plate is, say that is A, and the distance between them, these two plates, say that is D, then the capacitance of the parallel plate capacitor is given by C is equal to A epsilon naught by D. So here we are having one Q term and we are having C. These two I will substitute here. Therefore, Q means what? Sigma into A whole square divided by 2 into C means what? A epsilon naught by D. This is the energy. Therefore, this D will go up. Therefore, I can write U is equal to sigma square A square. This D will go up. That is D divided by 2A into epsilon naught. Here A and A will get cancelled. That is, I am getting sigma square A D by 2 into epsilon naught I am getting. Since just now we got that between these two, what is the electric field? E is equal to sigma by A. This is the electric field. Since we know that E is equal to sigma by epsilon naught, therefore sigma is equal to E into epsilon naught. Therefore here, this sigma value I will substitute here. If I substitute this, squaring will do. E square epsilon naught square. Therefore, E square epsilon naught square A D by 2 epsilon naught. Therefore, here 1 epsilon naught will get cancelled. Therefore, what is left here? Use E square epsilon naught A D by 2. So, as we have seen that initially, energy stored between the two plates in terms of charge potential or in terms of charge capacitor or in terms of charge capacitor and potential, there are 3 types we have seen, 3 different formulas we have seen. So similarly, if in terms of between these two plates, if suppose if you know the electric field and if you know the area of the capacitor and if you know the distance between them, then also one more formula also is there, that is this one. This is also equal to same formula, like that only. See, we can see from here. I have started from this formula only. This formula, this is also U, this is also U. Means I have substituted this value and finally I got this. That means this energy is nothing but equal to this only. So Q square by 2C, which is equal to half CV square, which is equal to QV by 2, and also which is equals to E square epsilon naught AD by 2. So there are, we can say, now one more we got, there are 4 formulas we are getting. So instead of electric field area distance, this is also one more formula. So this is the potential energy in this. Okay, but here I want energy density. What is energy density? This energy stored in a unit volume. Suppose if I consider a small unit volume I have taken. Suppose this is a small unit volume is there. In this small unit volume, how much energy is there? Unit volume, how much energy is there? That is called energy density, which is representing with letter small u. That is small u is equals to total energy by its volume. So total energy is this much. V square epsilon naught A D by 2 whole divided by volume. Volume of this space is nothing but area into this distance will give the volume of this plate. These two plates, in between the two plates, how much volume is there? That volume is given by area into this distance. So I can write here, this volume is nothing but area into distance. Therefore, area into D, this will get cancelled. Therefore, energy density is equals to, this is the expression. What is that? E square epsilon naught by 2. So, this is the expression for our energy density. This is the total energy between the two plates. This is the energy in unit volume. Energy per unit volume, this is the energy. This is the expression, which is called energy density. This is called energy density. Okay, fine. Now, let us come for a small conceptual points which help for solving a problem or need or J. Like, let us see some points. As we know that if the two parallel plates are there, this is the two parallel plate. This is the parallel plate capacitor of area A. Distance between them, say that is D. Then, what is the capacitance of this capacitor? Means we can say that the capacitance of this capacitor, we can say that C is equals to A epsilon naught by D. we have derived this one. If instead of this, between these two capacitors, a dielectric slab of dielectric constant K is introduced between this. This is the positive plate, this is the negative plate. Now, what is the new capacitance means we have seen for this also, that is C is equals to 1 K term will add up, that is K into A epsilon naught by T. Say its capacitance, say that is C dash. So, if only air is there, nothing is there, means we can say this as air or vacuum, we can say. Here, some dielectric medium, some insulating medium, if you place, then this is the formula. If it is completely filled, okay. Suppose this is positive plate, this is a negative plate. Now, in this, suppose a dielectric slab is partially filled. A dielectric slab is partially filled. Of thickness, say this is T, and this distance between these two, say this is D. Then, what is the capacitance of this capacitor? We have to calculate. So, for this, let us say initially, when there is no dielectric field, then the field will be moving in this direction. This is the electric field direction. That is, I will say it as a EO. That means outside electric field is this much. When this electric field is entered, then in this, whatever the positive, negative charges are there, they will get polarized, so that this positive is there. That means inside this, whatever the particles are there, the negative side, they will come. Negative will come this side. I will draw this a bigger one with you. Say electric field E0 is applied. Due to this electric field, here the inside this dielectric slab, they will get a polarized. That means such that here the negative and positive charge, they will be get separated, or they will be get polarized in such a way that the negative charge will come this side and the positive charge will move toward this side. That means inside also an electric field is created, which will be in this direction. Say that is EP. EP means electric field, polarized electric field. This one is outside electric field. So outside electric field is in this direction. Polarized electric field is in this direction. Therefore, the net electric field will be in this direction. Say that is E. Say that is E. E is nothing but is called net electric field. That is net electric field is given by E. That E is nothing but, what is the E value? This one minus this one. That is E0 minus EP. This field minus this field will give the resultant electric field in this dielectric slab is given by E is equal to E0 minus EP. This is called net electric field in this slab in this direction, that is given by this. Okay. Here, since we know that E0 minus EP is equals to E0 by K, also we can write. So instead of this, we can write here. E is equals to, here we can write that E is equals to E0 minus EP, which is also equals to E0 by K. So net electric field is given by E0 by K. So we got the expression for electric field inside there. So inside this slab, how much electric field is there means E naught by K we can say. Okay, how much electric field is there with E naught by K. So therefore, what is the net potential between these two? Therefore, potential between two plates is given by, that is V is equals to, potential between these two plates is nothing but is equals to the potential between the empty space plus the potential between this dielectric slab. So I can write here potential between the space and also the potential between the slab. So this potential, empty space potential plus this potential, if I add up, then I will get the total potential between the two plates. So since we know one formula, what is that? E is equals to V by R dV by dx. One formula is there. If I am actually minus should come, but there here I am taking a magnitude. So E is equals to dV by dx, or dV is equals to, we can write E into dx. That means potential is equal to electric field into distance, we can say. So therefore, if I talk about the space, that means potential energy in the space is how much, means electric field in the space, according to this formula, electric field in the space into distance in that. So what is the electric field in this space is, that is E naught. So I can write here as a E naught from that formula into, what is the distance in a space? What is the distance? The distance is nothing but, say this total distance is d, the thickness of this plate, say that is t. So therefore d minus t will give the empty space. So this empty space is d minus t. This is the potential outside the empty sphere. Empty space, how much potential is there? Means E naught into d minus t. Plus, what is the potential in the slab? In the slab, how much potential is there? Means in this slab, what is the electric field? That is E. That is E. And what is the slab thickness? That is T. E into T. Therefore, I can say E naught into D minus T plus, what is E means here? We know E means nothing but E naught by K. So therefore, I can write here E naught by K into this T. Therefore, here I can write, if I take E naught as common, then I can write here, what we can write? D minus T plus T by K. So this is the expression for our voltage V. So electric potential between these two plates is given by this much. This is the potential we can get. Therefore, now we can calculate the capacitance value. Therefore, general formula for the capacitance. What is the capacitance formula? We know that capacitance between the two is given by C is equal to A epsilon naught by, general formula we have C is equal to Q by V. General formula we know that C is equal to Q by V. Therefore, here Q by V. What is V means here? I can write this formula. That is E naught into D minus T plus T by K. So this is formula we can write. So therefore, and here also we can write. What is that? What is this we can write? This can also be written as, since we know that E is equal to sigma by E naught is equal to sigma by epsilon naught. We can write now. We can write sigma by epsilon naught. If I write that formula, if I substitute, then we can get here Q by sigma by, or otherwise I can write like this also. So you can write here charge is equal to sigma into area. So if I substitute this value here, then I can write here sigma A divided by E naught into D minus T plus T by K. We can write this value. And also since E is equal to sigma by epsilon naught. And sigma is equal to E into epsilon naught. See here, we know that E is equal to sigma by epsilon naught, sigma is equal to E into epsilon naught. If I substitute here, means here we can take E naught. Here I am considering as E naught, so that's why I will write here. Therefore, sigma means what? E naught epsilon naught into A divided by E naught into D minus T plus T by K. Therefore, E naught will get cancelled. Therefore, C is equal to A into epsilon naught divided by D minus T plus T by K. So, this is the effective capacitance between the two parallel plates if the dielectric slab is partially filled. See what I have calculated. First, I have calculated the electric field outside, which is nothing but E naught. Therefore, between these two, that is net electric field E naught minus EP. E naught is outside, EP means opposite one, which is polarized. So the difference between these two electric field is called electric field in this direction, which is given by this value. Okay. So after that, the potential I have calculated between the two plates. The potential between the two plates is nothing but the potential in the space plus the potential between the slab. So these two I have taken. So for this, the potential formula E into dx. So for this, E naught into dx means what? The empty space, that is D minus T. So D minus T. And for the slab, which is of electric field E of thickness T, E into T. E means nothing but E naught by K. I have substituted. So from this we got potential between the two plates. So therefore we know general formula C is equal to Q by V. So from that, V means I have substituted this value there. From this, I have calculated, I have written here, Q is nothing but sigma into area. From this formula, I have substituted. From this again, we know that sigma value we know. From this, E naught is equal to sigma by epsilon naught. Sigma is equal to E into epsilon naught. This value we can substitute here. Therefore, E naught will get cancelled. Therefore, A epsilon naught by this value will give the capacitance of a parallel plate capacitor when the electric slab is partially filled. So that means finally the capacitance for this is C is equal to how much? A epsilon naught by D minus T plus T by K. Say, if empty space is there, C is equal to A epsilon naught by D. If the dielectric slab is completely filled, then the formula is this one, that is C is equal to K into A epsilon naught by D. Only the thing is K is to be multiplied that much. And then if this dielectric slab is partially filled of thickness T, then what is the capacitance? Means A epsilon naught by D minus T plus K by T. Whether this is correct or not, to prove this one, let us see one example. Suppose say, if this dielectric slab is completely filled between the two plates, completely filled means this is completely filled. Then I have to get the answer like this, should be like this. This answer should become like this. So therefore, if this is completely filled, that means what? If completely filled means here this D should be equal to T. It has to fill. That means D and T should be equal if it is completely filled. Then if these two are equal, these two will get cancelled. If these two get cancelled, what is left here? A epsilon naught by T by K. This K will go up. Therefore, K into A epsilon naught by T. Here T can be written also as a T. So I will write this as T also. So K A epsilon naught by T, K A epsilon naught by D. So this is for completely filled. So if you fill completely, then D will become T, which is nothing but equal to, will get the same answer. So this expression we can use as a generally. This expression can be used for a generally if the dielectric slab is partially filled. Now, if dielectric slab is replaced by metal. Suppose instead of this dielectric slab is what? It is the insulating one, which is not metal. Okay, instead of this dielectric slab, if suppose I am placing a metal, if I place of same thickness steel, then what is the capacitance? Let us see. Suppose I am taking it as a metal, METAL. Suppose this is a metal I have placed. Say this is positive, say this is negative. So here, if I take a metal, for metal, keep in mind that for metal, the dielectric slab is infinity. Sorry, the dielectric constant is infinity. The dielectric constant will be infinity for the metals, whereas for air it is 1. For air it is 1, for metals it is infinity, for air it will be 1. So if I substitute this value here, therefore the capacitance of this capacitor when the metal is introduced, then from this formula, A epsilon naught by D minus T plus T by infinity. So instead of K, I have taken infinity. So therefore 1 by infinity, this entire thing will become 0. 1 by infinity is 0, 0 into T is 0. Therefore it will become A epsilon naught by D minus T. So if whenever a problem is given such that a metal of thickness T and which is kept in a distance D, then what is the capacitance of this parallel plate when a metal is introduced means this is the formula we have to write. Simply from this general formula, we have to take that K as infinity, make it 0, this is the formula. Okay, suppose if this metal is completely filled, then what happens? If metal is completely filled. If the metal is completely filled, that meaning is this T and this D should be equal. That means here the condition is T should be equal to D. So from this formula, already for the metal I got this much. So this T should be equal to D. If completely filled means then we can say that C is equals to A epsilon naught by these two will become D minus D. Both will become D. Both will become D. Both are equal. That means I can say both will get cancelled. Therefore, what is this? A by epsilon naught by 0. Anything by 0 is nothing but we get infinity. That means if the plates between the two capacitor is filled with a metal, that means if you fill with a metal, its capacitance will be increasing. If you fill entire capacitor is completely filled with the metal, then the capacitance of this capacitor will become infinity. That means it can store large amount of charge on the capacitor. Capacitance is increasing. That means now this capacitance can store large amount of capacitor and it can store large amount of electrical energy. See here, capacitance increases. That means what? It can store more energy and more amount of charge. So that means to increase the capacitance of a capacitor, one thing we can do. What is that? We can introduce the metal plate. If you introduce a metal, then the capacitance between these two will further increase than that of what it was previous one. Previously, it is only suppose A epsilon naught by D. Suppose here, if you take only A epsilon naught by D only. Okay, it is only A epsilon naught by D when it was only air is there. Suppose here one metal plate is introduced, then now the capacitance will increases. How much it is increases? That depends upon its thickness. If your thickness is increasing, this value will become further small, that is the capacitance will become further more. So in this how we can calculate the capacitance of a parallel capacitor by introducing a dielectric slab partially or completely filled or without dielectric, and also partially metal filled, and also if the metal is completely filled, we can say that directly that C is equal to infinity, infinite capacitor if we have. Okay, this is the concept which is to be keep in mind, right? So, okay, thank you everyone. So remaining topic we will discuss in a next class. Okay, still then bye.